In this course, we've talked a lot about how to architect and build microservice applications. But of course, before long, you are going to want to deploy your microservices to production. And while they're in production, you'll also need a way to monitor them and ensure that they're functioning correctly. I'm Mark Heath, and in this module, we're going to learn about some good practices for how you deliver your microservices into production. We'll start off by looking at how we deploy microservices. It's really important that we set up an automated process that can repeatably and reliably upgrade individual microservices. And we can achieve this by setting up a pipeline that can deploy code into one or more environments. It's also important that once our microservices are running in production, that we have a good way of monitoring them. And we'll see how having standardized health checks and aggregated logs can benefit us greatly when we're diagnosing issues in production. In the traditional world of monolithic applications, it's not uncommon for deployments to be a manual process, often where you follow a step-by-step Word document that explains how to upgrade to a new version of your software. But once you've moved to microservices, a manual process simply isn't going to work anymore. You've got far more things to deploy, and you also want to deploy much more frequently. And so microservices pushes us very strongly in the direction of automating our deployments. And that's a good thing. If we've got a reliable and repeatable deployment process for our microservices, that allows us to upgrade them frequently, as soon as new features or bug fixes become available. In fact, some teams using microservices deploy multiple times a day. So how can we achieve this? Well, we've already discussed how a continuous integration server can be used to automatically build our code whenever we check it in. And it's also very common for that CI server to run unit tests as well. But we can take this idea further. The CI server can trigger what's sometimes called a release pipeline. A release pipeline starts off where the CI build has finished. It's built the code and run the unit tests, but next we want to actually deploy the microservice, maybe to a virtual machine running on premises or to a cloud deployed resource. Once we've deployed the microservice, this is a great opportunity to run the service level integration tests that we discussed earlier on in this course, where we're testing that microservice in isolation. If it passes those tests, the next step might be to deploy the microservice into a QA environment, where it can be tested as part of the entire system. And this is the point at which you'd run any automated end-to-end tests. Now, at this point, there's often what's called a release gate. Just because our microservice has successfully passed all of its automated tests doesn't necessarily mean that we're ready to push it straight to production. There may be the need for some additional manual testing or some kind of risk assessment or customer sign-off before finally we're ready for this code to go to production. Once you reach the stage of being ready to push a microservice into production, it's really important that you use exactly the same procedure that you used to deliver it to the QA or staging environment for pushing it to production. It's very common that we want to be able to deploy our microservices to different environments. A developer might have their own virtual machine that they want to run a microservice on during development, and that will allow them to debug their code locally. And as we've just said, you might have a QA environment in which you're going to run your end-to-end tests or perform some manual testing. Sometimes you might have other environments dedicated to penetration testing or performance testing. And of course, another really important environment is production, where our code is actually being used by the end users. And in some scenarios, you have multiple production environments, maybe one for each of your customers, or one running in each of a few geographical regions. So it's really helpful to parameterize our automated deployment scripts, making the process of deploying to any of these environments as simple as possible. A common approach to dealing with this is to define each environment in a configuration file. And JSON or YAML are very popular choices here. These configuration files essentially express what's different about the environment we're deploying to. So here I'm showing an imaginary configuration file that expresses that the QA environment should be deployed in the West Europe cloud region, it should use medium-sized virtual machines, and scale between a minimum of 2 and a maximum of 5 instances of the virtual machine. And configuration files like this are often used in conjunction with other deployment scripts and manifests to allow you to deploy a specific version of a microservice into a specific environment. For example, it would be really nice if we could run a command like this, where we're asking to deploy version 1.0.4 of the ordering microservice into the environment that's defined in the qa.yaml file. And of course, this is just a simplified made-up example here, but there are all kinds of tools that you could use to achieve this, including Docker Compose that we saw earlier, or if you're using Kubernetes, that's got its own tool called kubectl that can apply the contents of a configuration file with a command that looks a bit like this. There are also technologies like Terraform and Azure ARM templates, which allow you to template the creation of the cloud infrastructure you need to host your microservices. And that might include virtual machines, databases, or blob storage accounts and virtual networks. And these too allow you to define a hierarchical set of scripts with base templates that are overridden with environment-specific configuration. To allow the deployment scripts to easily deploy any version of our microservices, we need the build artifacts to be stored in some kind of registry. That way we can easily deploy the latest version of our microservice or roll back to a specific previous version. In the eShop on Containers application that we've been looking at in this course, they've made the choice to build every microservice as a Docker container image. And using containers has many benefits, but one of them is the way that they are named and versioned in a standard way and can be stored in a container registry. And that means it's really easy when you're using Docker to identify which container you want to be deployed. Here's an example of what name and tag we might give to version 1.3.1 of the ordering service in our e-commerce example. Because the eShop on Containers application is using containers as a delivery mechanism, it's ideal for deploying to a container orchestrator such as Kubernetes. If you have a Kubernetes cluster, then you can define all the microservices in your application with some YAML manifest files. Kubernetes actually operates using a desired state strategy. Your manifest files define what microservices should be running and how they should be configured. And then Kubernetes compares what your manifests have asked for with what's actually happening right now on the cluster. If there's a difference, then it will add or remove containers until what's running matches what you asked for. And this means that upgrading to a new version of a service, or indeed changing any other property of a service, such as an environment variable or the number of replicas, simply becomes a case of changing the manifest files. And if you'd like to dive deeper into Kubernetes, I highly recommend that you watch some of the excellent courses here on Pluralsight that will guide you through how it works. A really good place to start would be this Kubernetes for Developers course by Dan Wah-Lin. We've mentioned before in this course how important it is that we can independently upgrade microservices. We don't want them to be tightly coupled in such a way that upgrading a single microservice requires all the others to be upgraded at the same time. And that means our automated process needs to be able to update just one microservice at a time, even if it can deploy them all at once, for example, if we were doing a fresh deployment of the entire application. So it's very important that you think about how you're going to upgrade an individual microservice. You might think that it's a simple case of just stopping the old one and starting the new one. And that's certainly a valid approach. However, it does cause a small period of service unavailability. And depending on what that microservice is responsible for, that may or may not be acceptable. But there are a number of other techniques that you can use to reduce downtime when you're upgrading a service. One is called a blue-green swap, where you run the old and new versions of the service simultaneously and then swap traffic from one to the other by means of a load balancer. And that means you don't have downtime while you're waiting for the new version of the service to start up, and so you should be able to get near instantaneous swap over. Another option, if you've got multiple replicas of a service running, is to replace the instances one by one. So if I've got 3 instances of version 1 or load balanced, I might, one at a time, add new instances of version 2 and remove instances of version 1 until all 3 are upgraded. Now, this does assume that you've written your code in such a way that having both versions running at the same time doesn't cause any problems. If you are using a platform designed to host microservices, such as Kubernetes, then many of these more advanced upgrade strategies are available to you out of the box. Another thing to consider is how seamlessly you can roll back to the previous version if anything goes wrong. This is another thing that a container orchestrator like Kubernetes can help you with, since rolling back is simply a matter of updating our manifest files to point at the previous tagged version of our microservice. Now, of course, you're only going to do a rollback if you've been able to detect that something about the new version isn't working correctly. And so that brings us on to another really important topic of how we can monitor our microservices.